This is a video about doing address locating in ArcGIS Pro. The process is very common in many different industries. Anytime you have a list of addresses, which is a type of spatial data. Addresses are a spatial reference. If you take like an intro geography class, in physical cultural geography, talking about types of location. One of the forms of describing location is absolute location. That is with like latitude, longitude, some specific coordinate set. Doesn't have to be lat long, but lat long is the most common. The other way of describing location of something is called relative location. So you have absolute and relative location. Relative location is based on a description. So you could do some kind of familiar description of like go down the street, turn left at the big tree, cross the river, and you're there. That's a description. If you tell someone where you are, you're usually using relative location as your description. If you're at PCC or if you're at home, you could, how would you describe that to someone else? Now, you may give your address as a relative location description. And addresses actually are a type of relative location. It's not a coordinate set, but it is this pretty sophisticated process that actually, if you have a complete address, you can identify any place on Earth. Think about the elements of an address. Most addresses may or may not have a country there. Like if there's not a country, it's kind of implied that the country is the same as where you are. And then an address has a state field, so California. And then an address has a zip code. So that zip code, like PCC 91106, is the zip code that tells you a section of the state that you might be found in. Zip codes are not the same as counties. They're just a postal descriptor. And then next part of that address, to kind of narrow it down, you've got country, state, zip code. After that is the city. Maybe it's an incorporated or an unincorporated area, but it's a city like Pasadena. And then you have a street. And so we've narrowed it down to a line feature inside of a city, inside of a state, inside of a country. So that's pretty specific. But on a line feature, obviously there are infinite points on a line. And so the address number is the location on a line feature where something exists. So again, it's not coordinates, but with that address number, you've got odd numbers on one side of a street, even numbers on the other side of the street. If you move in one direction, those numbers are going to increase. If you move in the other direction, those numbers decrease. And so the address for a location is spatial data. And from that, we can identify where pretty much anything in the world is if you have that address infrastructure. Now, in the United States and like developed countries, this is pretty standardized. In older countries, cities that were designed before cars, your address systems might be different. Some places the addresses are sequential, so like it's the order, the numbers correspond to the order that things were built in. In most of the United States, we don't do that. It's the number corresponds to location on a line, on a street. So the process of taking a table of addresses and turning it into point data is called address locating, or address matching, or geocoding. Those kind of all mean the same thing. Where you're building a spatial data set based on a list of addresses or a list of locations. Again, this is used by a whole bunch of different industries, organizations. 911 calls use address matching, and that's based on a reference data set. Every time you drive somewhere, that uses some geocoding to figure out what, how to make a point feature from the address that you type in. In like Google Maps, you can choose a point on the map and it'll route to that usually, or it'll do its best if there is a road. Um, uh, Address coding is used in crime analysis. A lot of crime data that's publicly available doesn't give the address, but it gives the street intersection, so crossroads. And so you kind of have to geocode that a little bit differently because it only has the street intersection rather than the address. Marketing people do it. Every time you go to the grocery store and you enter your zip code or your phone number in there, or your zip code, in some kind of marketing thing that tells companies where you live, what you're buying, and what to market you. Public land survey systems, PLSS, is a slightly different system that I don't use really ever, but there are some industries like archaeology usually is trained in PLSS, and it's this kind of weird thing that a township and range is an old way of mapping, and it was mostly used in like the kind of open west area where you have plots of land within plots of land before everything was organized into states, and so it kind of predates the modern. Well, we had modern addresses, but it was meant for when we had open spaces that weren't addressed. Kind of an alternative address coding is that nobody uses. It's called what three words. Let me switch the whiteboard here. Look up just in your own time what three words. This system gives a three-word description to every single location on Earth. And like totally unrelated to this topic, but it is an interesting thing. Let me share my screen and show this to you. I want to show you this window. This is what three words, and what three words is just a different way of locating things that is super interesting. It's on New York. Okay, whatever. Yeah, but if you zoom in, you can see this grid. Every box has a randomly generated set of three words, but those three words stay. So like if you click here, degree, post, pose, shuts. This one, final, flock, zest, slave, struck, fast, final, flock, zest. So that those words stay. But this is useful for places that don't have addresses. So like if you're giving a very rural location out in the Mojave Desert of like, oh yeah, we are camping out here. This is a place that I've camped before. We're camping out here. Whatever, that's fine. Here's this 3-meter grid, and it's got these three words: circus, frost, sheep, seed. And you can import that into Google Maps. The kind of disappointing thing is Google Maps just converts this to lat long. But it is a odd, unique way of finding locations. Stone Brewing has a beer, Fear Movie Lions, and that's it's the what three words code for their brewery. This is all off topic. But a unique way of address locating that nobody uses. It didn't really catch on. Maybe it caught on in some places. Now, the things that are needed for a address locating. There's a couple things. One is we need a reference layer. A reference layer is a list or a set of streets in GIS. And so let me share screen again. In Pro over here, we've got I've got two street layer. One is the street layer that you're going to use for the lab today. The other one is streets. 5 is kind of the way that I've organized it in terms of like scale. But interstate is the least detailed. Major highways is the second least detailed. Highways is the middle detailed. Major roads is the second most detailed, and then streets is the most detailed layer that I have. But this is for the whole US. It is a huge GIS layer. It makes the GIS, the Pro, not very happy. Well, it even has Canada, cool. But if we zoom in, like you'll see it takes a long time to load. It's going to slowly draw. And so what I've done for the lab today is I have selected a portion of this that is our PCC streets. And so the PCC streets is a big enough area to do the lab that hopefully won't crash your computers. So you're welcome. If you like these transportation layers, I can get them to you. I have them shared somewhere. I just need to remember where I have them shared. I think on the Canvas page, I think I have a link to this streets layer. Just beware, it is a big giant file that wants to crash your computer. And for the lab today, you only need this selection of it. Okay, so that is a reference layer. On it, we've got, it's pretty detailed. It's about as detailed as you're going to find, as you can get for a streets layer. It's got lots of different types of information. Okay, so that's our reference layer. The GIS is going to use that to figure out where things belong. The second step that we need is an address list. The address list in today's lab, the address list, let me share a different window. Yeah, the address list looks like this. So for the lab that we're doing today, this is something that I made, and then I had a student update it, so like she made a more complete version. So Jocelyn Hernandez, thanks for updating this a couple of years ago. It has been a little bit while, so it's not completely up to date, but it's good enough for us. So the fields here, we have the most important thing is you really just want to be consistent in your formatting. I have object ID, OID, the name of the restaurant, that's just for like labeling purposes once we make the map. And then I have the address formatted into 1, 2, 3, 4 different columns. The actual number and the street, the city and the state and the zip. You can have all of those in one row and it will work. You just don't want to switch between those two things in the same table. So like if you're making a table from scratch, look at your data, decide how it's formatted, and decide how you want to have it. You can do all in one field. So like, you know, all of these smushed into one field, or you can separate them like I have. It really doesn't matter. Just again, be consistent with what you do. Yeah, that's the most important thing. Okay, the third step, build the address locator and run it. That is what you're really going to be doing in the lab today is building the address locator. This has improved significantly from what it was in the past. This lab used to be a lot harder, and mostly because the address locators didn't work that well, and they're just a lot smarter now. And so when you run the address locator, you'll follow the directions in the lab. It's gonna run. and you'll have a list of addresses, or sorry, it's going to generate a bunch of points. The points are going to be your successful matches, and then usually it'll have a number of unsuccessfully matched addresses, things that either, you know, you had an error in your spelling, maybe a typo, the formatting was wrong. It could be things that there's like north or south Colorado Boulevard and doesn't know which side, or east or west of a street name. So maybe you left out the north or the south or the east or the west in the street name. It could be when you know, two things tie. So you have addresses that are too similar. And so UE can set the address locator to automatically match based on a certain threshold. And then you'll have your tied addresses. And so basically the steps for doing geocoding: get your reference layer, that's the streets, get your address list, that's the list of places you're trying to create spatial products for, match it, and then fix any unmatched addresses. That's the process, that 4-step process. Okay, so one of the kind of practical applications of this, I'm going to share my screen again, is when we had the wildfires in January 2025. That you know, was obviously super close to campus, affected many people connected to campus in lots of different ways. We had lots and lots of students, staff, and faculty either lose their homes or have to be evacuated for a number of days and like have lives severely impacted by this. As the fires were happening, our campus didn't really know how this was affecting our community. And so our Office of Institutional Effectiveness didn't have this ahead of time, but I worked with them to geocode addresses for our community members. I then immediately after generalized the addresses, and so what you're seeing here is this is dots of staff and faculty locations, is gray dots. Red dots is students. Gray is just staff. These are generalized, so these are not real addresses of where people live. What I did was, after geocoding them, I did a point in polygon count where I basically counted the number of points in census blocks, and then set one address equals one dot. So kind of a clever way of generalizing data. And so, like, as you zoom in, you'll see the dots jump around. These locations are accurate on the block level, or the census block level. So they jump around, and it doesn't show, like, we're not really, it is sensitive. I'm being careful, but this is not violating privacy because these are generalized. And so I only ever showed the generalized one. But after creating this, our Office of Institutional Effectiveness worked with local organizations and secured a bunch of money in relief funding for people. It was over $1 million something in relief funding. And really the point of it was, like, how do we know who's been affected? How many people? And so I kind of just did another point in polygon count for the burn area. Here's the fire perimeter. We had 86 staff homes, 172 additional staff and faculty within a half mile of the burn area, 258 that, you know, severely affected. It was just a calculation I came up with. 655 student homes in the burn area. Additional 1,500 within a half mile, so around 2,000 severely impacted. This was you know, kind of unique, but we use addresses, generalize them for privacy, and then point and polygon counts to see the number of people affected. this data, I mean, you could use this for I don't know, any number of purposes. We don't because it's kind of sensitive. Again, this is generalized, but really just one of the potential uses for geocoding that is a powerful tool. These squares here are campus locations. In one of the iterations of the map, our campus board of trustees wanted to see um, within their trustee districts. And so I had that on there at one point. Oh, actually, I do still have it on there. That's what these gray lines are, trustee districts. So like if you live here, your trustee member is Tammy Silver. If you live here, then your trustee member is Linda Waugh, so on. That's a different map that I've made those trustee districts for the campus as well. But just another application for geocoding. Great use for emergency response to see who needs help, who lives inside this perimeter, and how our community was impacted. Okay, so address locating, obviously an important tool, useful in lots of different situations. The lab today will be in Pro, but ArcGIS Online has recently expanded their capability in geocoding. So you can complete this lab in ArcGIS Online. It might just take a little bit of figuring out, but like take the data after completing in Pro, take the data, see if you can create an equivalent map in ArcGIS Online for fun. All right, enjoy.